Hello, welcome friends. Me Anila. The topic of my discussion is about toughest numericals on Fehling test part 3. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on Fehling test. Before going to the numericals, I would like to tell you something about Fehling test. This test is performed for the detection of reducing sugars like glucose, fructose, lactose, maltose and aldehydes, but not sucrose because sucrose is non-reducing. This test only detects reducing sugars. This test consists of Fehling solution A, Fehling solution B. Fehling solution A contains copper sulfate blue color solution. Fehling solution B contains potassium sodium tartarate in strongly basic medium, that is in sodium hydroxide. The procedure of this test is add equal amounts of Fehlings A and Fehlings B, add sample containing aldehyde or reducing sugar and heat. The observation is because in this test aldehyde reacts with copper in strongly basic medium to form carboxylate ion, copper 1 oxide and water molecules. So aldehyde reacts with copper, that is blue in color, and the formation of copper 1 oxide, which is red precipitate. So if blue color remains same, the test is negative, no reducing sugar present. If color changes from blue to red, that means test is positive and reducing sugar is present. In this video, I will tell you how to solve toughest numericals on Fehling test part 3. Example number 1. Fehling solution contains 0.09 moles copper plus 2. After reaction 0.03 mole copper plus 2 remains unreacted. Find moles of aldehyde. So as I have discussed is earlier that in this example the total moles of copper plus 2 that is reacting is 0.09 moles and 0.03 moles copper remains unreacted. So we can calculate reacted coppers, and when we will calculate reacted copper, then from this we will apply mole ratio between copper and aldehyde and then calculate moles of aldehyde. Solution. So reacted copper is equal to total copper minus unreacted copper. 0.09 mole minus 0.03 mole, we will subtract unreacted copper from total copper to get reacted copper, that is 0.06 moles. So this is reacted copper. We will apply mole ratio. 2 moles copper reacts with 1 mole aldehyde. This mole ratio I have told you earlier that 2 moles copper reacts with 1 mole aldehyde. So 0.06 moles copper react with. We will multiply 0.06 by 1 and divide by 2. We get 0.03 moles aldehyde. So we have calculated moles of aldehyde. Example number 2. A 16-gram impure aldehyde sample gives 7.16 gram copper 1 oxide. Find percent purity of aldehyde. Molar mass is 90 gram per mole. So, in this example, amount of impure aldehyde is 16 gram, and when this aldehyde reacts with copper, that is Fehling solution, it produces 7.16 gram copper 1 oxide. We have to find percent purity of aldehyde. Molar mass of aldehyde is given 90 gram per mole. Solution. So first what we will do, amount of copper 1 oxide is given, we will convert this amount into moles. And when moles are given, we will apply mole ratio between copper 1 oxide and aldehyde. And then aldehyde moles are calculated. After that, mass of aldehyde is calculated. And after the mass, we will calculate percent purity of aldehyde because impure aldehyde sample is 16 grams. Solution. First, we will calculate molecular weight of copper 1 oxide is equal to 2 is the number of copper atom into 63.5 is the atomic weight of copper plus 1 is the number of oxygen atom into 16 is the atomic weight of oxygen. After solving, molecular weight of copper 1 oxide is calculated to be 143 gram per mole. Now we have calculated molecular weight of copper 1 oxide. Mass of copper 1 oxide is already given in the example. We will calculate moles of copper 1 oxide is equal to mass 7.16 gram divided by molecular weight 143 gram per mole. After solving, moles of copper 1 oxide is calculated to be 0.0493 moles. Now we will apply mole ratio. 1 mole copper 1 oxide is produced by 1 mole aldehyde, as I have discussed earlier in my previous slides that 1 mole copper 1 oxide is produced by 1 mole aldehyde. So 0.0493 moles copper 1 oxide is produced by the same moles 0.0493 moles aldehyde. We have calculated moles of aldehyde. Molecular weight of aldehyde already given in the example 90 gram per mole. Now we will calculate mass of aldehyde is equal to 0.0493 moles into 90 gram per mole. After solving, mass of aldehyde is calculated to be 4.437 grams. We have calculated mass of aldehyde. We have to calculate percent purity of aldehyde. For this, the sample amount is 16 gram and the mass of aldehyde produced is 4.437 gram. We can calculate percent purity of aldehyde is equal to 4.437 gram multiplied by 100 divided by 16 gram. After solving, percent purity of aldehyde is 27.73%. So the sample is 27.73% pure. That means aldehyde is present. In this way, Fehling test is performed. Friend, if you have any question, you can ask me on comments. I can help you. Thanks.